Aloha, Richard Halverson here. Oops, what's this? Sorry. This is ITS128, and today's Thursday, January 28th, and it is the fifth, I think this is the fifth video of this spring 2021 semester. And so let me share my screen. Okay, so we are in, so if we go to the syllabus, oh, I popped it up right here. We are in this week, week 3, it appears. We're starting chapter 3 in types. And now there's a lot of sections here, but I'm not sure I need to spend a lot of time on every section because around this time last semester is when I started, recording, or I started doing my classes where I really did spend a lot of time, like doing the challenge activities and the labs and so on. So I will point you back to where those videos are. But anyway, so I'd like to get us through chapter 3 today, where we understand exactly what's being asked in all of the places where there's doing it. There are assessments, and so you should just be able to, if you're familiar with this stuff, it comes pretty easy for you. You shouldn't have to go back and refer to the videos, but they are there if you need to. All right, so if we look at the okay, so why don't I show you that first? I think, I think this might be the student. Is this like the student? I was messing around with my student account, but in ITS128, if you click on resources on the left, this looks like more like yours, not like mine. I got a bunch of other crap in resources. But if you click on this spring, it's okay. Spring 2021 videos are right here. Oops, I forgot to put the fourth one up. But the fall 2020 videos are here. And so you see, today we're covering chapter 3, and in the fall, those were covered in these 3 videos here. When you open up these videos, like for example, let's take a look at programming exercises right now. This is from last semester. I want to point out to you that, and I just learned this. I mean, I'd been using YouTube for a long time before I noticed this, but down here, well, closed captioning is nice, but down here, you can click on settings and quality. My default is 720, but you can put it up at 1080, and then it's high definition, and then the video is much better. And of course, you want to have nice videos, so when you when you want to see the code,
cover Xylabs.
So anyway, those
programming exercises in the back of chapter 3.
So these are all available for you in the resources. So like, even if you want to jam ahead with the course, you can do that. But last semester I didn't cover chapters 10 and 11. This semester I am covering 10 and 11 because I think they're important. I'm actually covering 10 and 11 in 148 this semester right now, so I should have some videos ready for you at that time. Anyway, so let's go to chapter. Oops. So let's go to Zybooks. So we're in chapter 3, and let's start out with types. Okay, types is all of the different basic types that variables can be. We know about integers that are just whole numbers, and we know about floating point numbers that have decimal points, and we also know about strings. There are strings of characters that can, where you can put everything else that's not just strictly digits into. And this thing covers all of them. There's lists and sets and dictionaries also. So let's start here with string basics. One other thing I want to point out is that you need to recall that we do know all about input and output from section 1.3. Section 1.3 covers printing both kinds of print statements, and with the end, with the where you don't want it just to do a return. And it also covers inputs, the input, which is reading from reading, and then it also has where you do this type conversion, where if you want to read in a number, you put this int around the input, and then what comes in is like in this case an integer number. So I just wanted to remind you of that. That's something that's used throughout. Um, let me open up just in case someone's got a chat. So a string is a sequence of characters, and you know, it's characters it's characters that have, you know, set positions, and string indexing involves identifying you know, characters specifically by their position. So in this case, you know, the indexing index 0, 1, 2, 3, 4. We always start at 0. Is the position or index of these letters of the characters here in this string, which is somebody's name, Trish. And you know, if you should, so you change this and you get the participation. Okay. Here, there's no participation, but it's interesting to just run these and see what's going on. And the code is here. This is this Mad Libs game, and you know, we see this Mad Libs game, you know, in the lab exercises, and basically it takes an input. You know, it takes an input, and these are the inputs, and it writes out a dumb sentence, okay? And this is the code for it, okay? And in fact, you know, so you may even want to refer back to this code later on when we have an assignment, a lab that uses that has you do some form of this Mad Lib exercise. All right, and then it defines strings. Okay, so this goes through and does string basics. And if you have trouble with any of these, you can go to specifically to those these videos. Like right now, I'm in 3.1 to 3.3 here. Okay, so there's functions that can be used on strings. And so here we have for example, okay, so this is a couple of things here. Let's say you want to write a string that's so long that you want to use more than one line. Well, here, you know, you're writing this string that's got all this in it, but you want to you know, use more than one line. This is how you do it. You close the quote, you start the quote, and then you close the quote and put a backslash, and then go to the next line and start the quote again, and then continue, and you can keep on doing that, and it's going to end up all being on one line. It's not shown here, but it is. You can, you know, you can prove it to yourself if you want to, but okay, so and then this is another way to do it, and this is a third way to do it. Okay, so but this len function, which will give you the length. So you inside here you put the string, and then it's inside this len parentheses, and what this ends up printing out is the actual length and the number of characters. So it turns out that if you count up all these characters, it's going to be 185. This here, there's 26 characters here, and there's only 3 characters here. See, that's this is the length of this variable, and this variable is here. This is the value of this variable, and that's this variable, and this prints out the length of the number of characters in that value. Anyway, okay, so that makes you understand length, and then this is indexing, where you want to identify a particular character. So, you know, there's a string. This is it. And you want to print out the first characters, the very first character, and so the index is 0. So that's how, if you put that there, then what's going to print out is the value of alphabet left bracket 0 right bracket, which is this one right there, that's what prints out here. And this is index number 1, and this is index number 25. This is index number 25. 0 through 25 is 26 characters. And this is a nice little program which says you give it the index here. Let's do 24, and you run it, and it's going to tell you that the letter 24 is Y. What happens if we put 26? Boom. See, it's that number is out of range. Out of range. And so this is an error that's produced by the Python system. And in fact, in chapter 9 or 10, which is one of those chapters that we skipped last semester, but we'll cover that later. And later this semester, we will learn how we can actually capture that error as it occurs and keep it from bombing your program. And you can say, hey, you typed in an index that was too big. Anyway, so that's but we aren't there yet. So here's more on string indexing, and then here's if we want to change string variables. Now, a string is how you say immutable. Okay, and immutable, if you want to know what immutable means, it's just what you think. If it's mutable, then you can mutate it. You can change it. If it's immutable, that means you can't change it. Okay, so a string, you cannot change a string by doing this, by changing the particular character of a string to where you're indexing a particular character, and you're putting that on the left side of an assignment statement, and you want to change the value of that to capital A. You can't do that because strings are immutable. Now, it turns out that this particular syntax looks just like if you have a list and you have an index of an element in the list, and you want to change an element in a list. Okay, so I'm talking about later on in this chapter, not here. A list is mutable. It's not immutable. A list is mutable, so you can do that in a list, but in a string you can't. Okay, so this will cause you to bomb. This will cause the system to bomb. Now you can concatenate. But you can do something. What is this? Oh, yeah, okay. No, all this is saying is the way you do it is you have to create an entirely different string. If you want to change this, if you want to change the first 2 characters to capital A and capital B, you have to make a brand new string, and then you can make this point to the brand new string if you want to. But then this is just gone. All right. There's string concatenation, and the way you connect 2 strings together is you use a plus sign. So if you want to concatenate, let's say you concatenate A, B, C, this string 1, with string 2, like this, and you've made a new string called that, and you want to write that out, that's going to be what this is right here. So you see it's the first string concatenated with the second string. And we use a plus sign. Plus sign is the same plus sign we use to add two numbers. We use a plus sign to add two strings. But when that plus sign is used, it means a different thing if it's in between two strings. It means the plus sign means something different if it's in between two strings than if it's in between two numbers. And oh, by the way, if you put a plus sign in between a string and a number, it's going to be an error. All right, so that this thing sort of reinforces those two concepts. Here we're just printing. You can look and figure out what that is. Looks pretty simple. Here we're just figuring out how to read multiple data types, and we're supposed to put this here, and that's going to read in a variable name, and then we want to print this out where we read in. We want an input statement to read in the person's name, and we want an input statement to read in the person's age. And for the person's age, we have to use this int around the input. You know, it's kind of like back when I showed you section 1.3, where you put the int around the input, and that's what they want you to do here. And here we are concatenating strings. Here we have a nice date here, and then we want to put something that looks like the date followed by, oh, the colon is there already. So then it's going to be a space, and we want to put Houston. So I guess the log entry is the date, is current. Log entry equals current time. Wait a second, is there a function for that or something? Do not write a prompt for the input values. Oh. Oh. All right, do not write a prompt for the input values. So what, am I just supposed to do this? Houston, oh, no. And make assignment statements, I guess. Anyway, you can work on that one. I want to get through this. So here, okay, now we're talking about lists. Okay, so remember, it's in some ways it's much like a string and characters. We have a list and the elements in the list. And so here you have a list, and here you got two elements in the list, element 0 and element 1. Okay, and called an element. Okay, so we have strings and characters, and we have lists and elements. And we index the same way, and something like this creates an empty list. And so we can create a list like this, and we can write out when you declare a list, you're declaring you're reserving slots. You're reserving slots. It's a different process than a string, because a string characters are all the same length. They're like, they used to be just 1 byte, but now they're like 2 bytes or 4 bytes or something, and they're all the same, and they're all in a position, and you can store them in memory. And because every character is the same length, if you want to find index number 50, you can just do a calculation, and you would add it to the 4 times 50 is 200 plus the address of the first one, and you get right to the address of the particular indexed character. It's not quite so easy in lists. The advantage of lists, though, is that they are immutable. It means you can just change the third element. That makes them handy in other ways. So you want to go through this accessing elements of the list, same thing. Here we're defining three variables, and each of these variables are integer numbers, it looks like. And then we're defining this list, and the 0th element is this value, which is that. The number 1 element, index number 1, and this is the value, and this is the value for index number 2. These are values that go in there because these are actually variables here. And here we're printing a string, which is this is what we're printing. And then we're printing the index number 0 of the prices list. Well, here's the prices list. Here's index number 0, and that is a variable that has of this value. So that's what gets printed here, followed by the word dollars. See, anyway, so that's that. And you can look at that. Updating list elements. You can have a list element, indexed element of a list on the left side of an assignment statement, unlike strings and characters. All right, so write a statement that assigns my var with the 3rd element of my list. What is that? Something like my var equals the 3rd element of my list. Would that be something like this? Is this a trick question? Yes. All right, adding and removing list elements. Okay, so since lists are mutable, a programmer can also use methods to add and remove elements. That's right. With a string, you can only concatenate, something on the end of the string, but you're actually creating a new string that way. When you're adding and removing elements from lists, you aren't doing that. You're actually attaching something onto an existing list. You're not recreating a whole new list. You're just really just attaching something onto or changing something in the middle of a list. All right, so you use this append, which is used to add a new element to the list, and you can remove them by using this pop or remove. And that has to be this has to do with whether it's removed from the front of the list or the back of the list, I think. And then append is only appending on the appending onto the end of the list, the back end of the list. And I think that maybe there's push to push something onto the beginning of the list. I don't know, we'll see. Depends on the language. All right, so here we're adding something to the end of the list. Here we're popping something off the beginning of the, removes the element at index. Oh, no, pop, you can actually put an index in there. So that's a way to remove something from the middle of the list. Okay, that's right, okay. And what is remove? Okay, I'm sorry. Forget what I said about a minute ago. I'm not going to go in and slice that out. That's too small of a deal. Pop has an argument, and what it is it's the index of the element of the list that you want to remove. Now this is a different kind of method where you put a value in there, and then it'll go in and remove the first element that's that value. So here, this thing will remove the 0, 1, the second element of the list. It'll just take it out, and everything else will shift up. And this will search down the list to try to find the first element that's of this value, and then it'll remove that one and shift everything else up. So assume that update, this says how you can update the price of the second. Okay, so that's just on the left side of us. That's just an assignment. Add, this is an append. Remove the first element of housing prices using the pop, so that'd be pop 0. And remove 140, so this is remove, and you you just put this without the dollar sign and without the comma. You put that as a parameter, as an argument inside the remove there. Sequence type functions. Okay, so some of the functions useful to lists. This will give you the length of the list, just similar to strings. Gives you the number of characters. This gives you the number of elements. Here you can, this is a way to concatenate list 2 onto the end of list 1, just like strings. This is to find an element in the list with the smallest value. There's this min function. It goes through all the elements of the list and remembers and returns to you which one was the smallest value. This is the largest value. And then this is the, if you want if the list is all numbers, you can do this sum function, which will go through and add them all up. And this will return, and the way you use this function is you use it as the dot notation, where the list and then dot index, and then you put a value there, and it's going to return the index of the first element of that matches what val is. And this will actually count up the number of occurrences of val in this list. So you can see how these work. And so, you know, the idea is to go through here and make these be checked off and make these be checked off. List the functions and list functions of the list class and methods of the list class. User ages. What is the value of the length of user ages? 1, 2, 3, 4, 5. Oh, 5. I get it. 5. 1, 2, 3, 4, 5. What expression changes pop 2? 0, 1, 2. Pop 2. Okay, you use those functions the same way, of course. Okay. Yeah, those, append and pop, and the other ones, well, anyway. All right, what's next? So this is just adding the two together. Can you append a list to a list? I guess you use append if you want to just append one element, but you use a plus sign if you're adding two lists. This one. So anyway, what's next? Oh, we on to sets. Tuples. Similar to list, but it is immutable. Once created, a tuple's elements cannot be changed. A tuple is also a sequence type. Okay, so order matters. There's a length. Wait, is that true that order matters? For set order. A tuple is not as common as a list, but is useful in a program with sure values do not change. Okay. Typically used when element position and not just relative ordering is important. Okay, a tuple might store the latitude and longitude of a landmark because the programmer knows that the first element should be latitude and the second element should be longitude. and the landmark will never move. Okay, so with a tuple, a tuple is the same as a list, but it's not mutable. Can't change it. That's all. And it's expressed a little differently. It's expressed with parentheses instead of square brackets. But you can index the elements. You know, you say there's a 0th element and a 1st and a 1th element. Okay, so that's tuples. I guess you can have named tuples. I don't use tuples much. Where the first, you have to import a class called named tuple. Define a simple type that consists of named attributes. Oh, I see. Okay, well, anyway, that doesn't seem like it's that useful, but you should learn the concept, and you may come across someday an opportunity to use this. Okay, this is a define a named tuple called player that describes an athlete on a sports team. Name, okay, so this is, so here you're going to define the tuple, and here you're going to be initializing, you're going to be creating, you're going to be using this tuple type that you define to, and there's going to be one called Cam and one called LeBron. And so defining a player, these are players, must be like this. There's name and there's number, and there's this name, number, position, and team. So this player tuple, or this player named tuple, will be player parentheses name parentheses where is it? It's called a name tuple, and the first parameter is going to be player, and the second, and then there's going to be a left bracket and a right bracket, and inside there's going to be name and number and position and team. So so anyway, you can work on that. Okay, if you have any questions, you know, you can just type them in. If you're shy, just type them in the chat. All right, sets are a little different. They're like tuples. Wait, are they immutable? But there's no order to sets. Okay, they're either like lists or tuples. I'm not sure, depending on the mutableness. Sets are mutable. Okay, so they're like lists. They're not like tuples. They're like lists. But there's no order to them. So they aren't indexed. They aren't indexed. You know, remove and can be added, removed. The add method places a new element into the set if it does not contain the element. The other thing is there, since there's no order, so Heather, you just asked a good question. You can make sure that that it doesn't have any duplicates, but you'd have to write a little program to do that, which would be pretty easy to do. You know, you can just see if the index exists, and if it doesn't exist, then you know it's not in there. If it does, then you know it is. But you can use a set if you care about duplicates. If you don't want to have duplicates and you don't care about order, then you can use a set. And it's add instead of append, and remove and pop. Now, is the argument of pop a value or an index? Can't be an index. You know, with lists, it's an index, but there's no index in sets, so this must be a value. Remove an element from a list. Okay, there's a length, which tells you the number of elements in the set. To check if a specific value exists in a set, you use a membership test such as value in set. Okay, so this is how you do it. Which is discussed in a later section, I guess. Okay. So this is how you add something to a set. This is how you remove something from a set. Oh, there is no argument. This just removes a random element. Okay. I guess that can be useful sometime. Removes a random element from the set. Okay. Clears all the elements from a set. This removes a specific value from a set, and it raises a key error exception, if that's, and we'll find out about exceptions in chapter 10. It's kind of what I was talking about earlier. All right, so you can modify sets, adding, updating. So updating is how you concatenate two sets, or how you add two. In lists, you use a plus sign. It's an infix operator, an infix function. You just use a plus sign, but in sets, you use this update method, and you put the second set as the argument to the update method. This is how you remove, and then this is clear. Okay, great. Modifying sets. Okay, and so this is how you define set. This is how you define a set. You use curly braces. You also use curly braces for dictionaries, but in this case, we're just using them for sets. But we also use them for sets. The syntax inside of the curly braces is different for dictionary, and I think we covered dictionaries in this chapter. Okay, so here's some set operations. You know, sets. You think of sets, and you learn about sets in I don't know, Philosophy 101 or the logic course or whatever, or a discrete. This is 128. I guess we don't have to take discrete math. So this will return a new set, which is the intersection, union, differences, the difference between set B and set, anyway. So symmetric difference. So these are different kinds of operations, and are they described here? I believe so. And so it's pretty good. It's pretty important to learn to understand these terms, because if you ever are writing a program where sets is the data type that you're using because of whatever the constraints of the program are, you'll want to know how all these work. You'll probably imagine that these methods exist, though, because when you're starting to work with something, it kind of, if you can think of it, they've probably thought of it. Okay, here's dictionaries. Now, dictionaries like a list, except for it's got like a second parameter. It's got instead of an index, it's got a key. So a dictionary is a bunch of values. Like a list, it's a bunch of values. A list is a bunch of values. A dictionary is a bunch of values. With the list, you refer to the different elements by the index, its position from the beginning. It's how far it is away from the beginning of the list. With the dictionary, that there's a key value that's associated with every element, and that's how you refer to elements inside of a list or inside of a dictionary. That means you got to know what the key value is. With the list, it's nice because if you want to know what the first element is, you just say list of 0. You want to know what the fifth element is, you say list of 4. For a dictionary, you say, well, tell me an element in the dictionary. I have to come back to you and say, well, you tell me a key first, and then I can tell you if that's in the dictionary. So anyway, so here's an example of, okay, and use curly braces just like sets, okay? So here's how you define a dictionary. And the key is, this is the key, and this is the value, and this is the key, and this is the value. So if you want to list out all the keys of a dictionary, which you can do, you're going to get back a list of these names here. If you want to produce a list of the values in the dictionary, you're going to be returned a list of the values. Okay, so all of those functions are available. By the way, here's where it's important to be using Python 3.7, which we are, and this thing supports. But if you're installing Python on your computer at home, you want to make sure you get at least 3.7. So here's creating a list, and so here's a list of where we're creating the milligram of something per 100 milligrams of caffeine, and then this prints out a dictionary. So this is a nice thing because you want to see what it looks like when you just print out let's say you define a dictionary and you just want to print it out to make sure that it's got everything that you want. Let's say you create a dictionary with a program where you're plugging elements in. Anyway, so you run it, and this is what it looks like when you print out a dictionary. It looks like this. I'm going to copy this. Copy. And I'm going to open up some kind of editor. And I'm going to paste it. And you can kind of see that it's this, 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 this. See, so it's kind of this, you know. So it's 1, 2, 3, 4, 5, 6, 7 elements. No special order. If you want to refer to the caffeine content of Lipton Brisk iced tea, lemon flavor, you say, what is the, whatever the name of this list is, what is the caffeine content of this? What's the caffeine content of that? And it's going to return to you this. All right. Oops. What is that? Where am I? Okay, let's go back here. Time is it? 11:15. So creating a dictionary, this is how you create a dictionary. And then so see, this is how you refer to the price of apples, price of lemons. I'm sure a dictionary is mutable. Dictionary is mutable. You change stuff. You change stuff how you'd think you'd change stuff. You have a dictionary and you want to change. This is a key value. This is the key, and this is the value. Okay, this is the key. This is the key, and this is the value, and this is the name of the dictionary. This is how you delete an element of the dictionary. So where's adding? Is it append? Adding, modifying and removing dictionary. It's mutable. You add a new dictionary, add using braces. Oh, this is how you add. You just define it. You say, I'm going to add a new value for banana, for the price of bananas. There's no append or add or anything. You just say, well, prices of banana is equal to that, and then it's created. But you do use this delete to delete. So you don't like set it equal to 0 or anything. All right, so that's easy. Common data type summary. Oh, here's a nice summary. Well, that's nice. Are we that? Let's. Okay, so this, it's good to go through this. Choosing a container type, list tuple dictionary, so on. Okay, what's next? 6. What? Where are we in this chapter? Binary numbers. Okay, let's look at type conversion. So Python does not want to guess what you mean. It makes you, well, there in some ways sometimes it guesses what you mean, but in most cases you have to actually explicitly say what the conversion is, because you're converting an integer, like you're converting, if you're converting 1 2 3 uh, as 3 characters, the character 1, character 2, string of string 1 2 3, or integer 1 2 3 123. Of course, those two things are represented differently inside of the Python runtime machine. They're represented differently in memory. And so if you want to, define something as a string, and you want to use it like an integer, you can't just do it like you can in other languages. PHP, you just say, okay, I got this string, it's 3 characters long, but it's all digits, so I'm going to treat it like a number, and lo and behold, it just works. With Python, it'll say, whoa, 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 you can't do that usually. But there's this implicit thing where if it's so obvious, it lets you do it. Conversion automatically made by the interpreter. It's usually between numeric types. So if you're doing an arithmetic operation using plus or times, if you're doing like a float is on one side and an integer is on the other side, well, it's going to assume that the result is going to be a float. Okay. So this is going to end up being an integer type because they're represented differently inside the computer. That's all the way down to the microprocessor. They're represented differently. And this is going to return a float because we have a float here, and you can convert an integer to a float without losing anything, but when you convert a float to an integer, you might lose. You lose what's to the right of the decimal point. All right, so that's pretty obvious. Otherwise, you want to use these explicit methods here, so this converts creates integers. So the argument can be of course it can be an integer. I don't know why you'd want to do that, but it can be a floating point number, or it can be a string, but the string has to have integers only. You can create a floating point. Fractions. No, I think they must mean with a decimal point. And then a string, you can have anything be inside for a string. So and if you create a floating point, no, if you create an integer from a floating point, of course, it's going to get rid of what's to the right of the decimal point. All right, so go through that. Okay, so binary numbers is a little different. Now, why are we covering binary numbers here? I wonder why we're covering binary numbers. Okay, anyway. Normally, a programmer can think in terms of base 10 numbers. However, a computer must allocate some finite quantity of bits for a variable, and that quantity of bits limits the range of the numbers the variable can represent, of course. Python allocates additional memory to accommodate very large numbers, and the Python programmer need not think of such low-level details. However, binary-based computation is common and important, an important part of computer science. So background is influences. Yeah, you can kind of. Okay, so you've all seen, you all understand binary numbers. So when we talk about when we talk about decimal numbers, each digit is a number between 0 and 9, and each position is a power of 10. So this is like 2, well, 212 is 212. It's 2 to the 10th, to the 2 times 10 to the second power, plus 1 times 10 to the first power, plus 2 times 10 to the 0th power, which is 200 plus 10 plus 2, which then equals 212. That's really what's going on when we write 212. This is how we sort of added up to that. For binary numbers, it's not 10, it's going to be 2. And so you can only have digits 0 and 1. And so 1101 is 2 to the third, 2 to the second, 2 to the first, and 2 to the 0th. And so it's, you add it up that way. So this is equal to 13. But of course here these are all base 10 numbers, anyway. So it's kind of good to go through this. Is there's challenge activities, make this a decimal number. 110 is a, oh, is this timing me? I don't know. Anyway, so you can do that. String formatting. Oh, this is pretty important. We're starting to use this format function now. And it's so you can format outputting of strings. You see, so we use this. Okay, so the way we do it is we define the format first. We define the format and we put it inside quotes because it's a string that we're defining, and the string is the format. And then we do this dot format word, and then we put the value or the variable names or values that we want that are being formatted, and order counts. So whatever this value is, which is 6, that's going to go here. You use these curly braces things. And this value amount is going to go in the second one. Okay, so that's why it's going to print out like this. 6 burritos cost $, and the 32. So this is pretty important to know this stuff. Oh, really? The cat. Oh, you can do this too. You can do these positional things. Here you're actually saying the order. Here it's just inferred positional replacement. And here you're actually doing a thing like a dictionary, where you're saying, this is the animal, and this I'm defining the values using the format. Okay, so this is how you format. Pretty important to know how to do this. You may be referring back to section 3.9 often until it sticks in your head. These are little formatting parameters, formatting specifications, presentation types, and it's so you can say when you're writing out decimal values, you can say you can specify different formats. This is this is an important one. It's you're writing out a floating point number, but you want to limit the number of digits to the right of the decimal point. So you do this. You put your variable name in there. In this case, we're just putting 4. But then this is the format. And what it is it's any number of digits to the left of the decimal point, and then just 2 digits to the right of the decimal point. And we're talking about floating point numbers here. That's the F. All right, so you can make sure you understand that. Say some 2 digits to the right of the decimal point. Looks like it's a $sign value and so on. All right, very good. Wow, this is good. Okay, 3.9. Remember that. All right, what's next? Health data. Oh, this is another application. What is this? 22. Enter your age, 22. You are at least 8. Oh, okay, so I'm going to put my real age here. I'm not shy. I'm going to retire soon. Whoa, look at how many days old I am. My goodness. All right, so anyway, and this is the code. All right, what's next? Okay, so now we're into the labs. And I think, you can just, try these yourself, go through, try them yourself. If you can't figure something out, you can go back to the fall and you can click on here, this one, programming exercises, class number 7. And it looks like this. And here I go pretty far here and showing you how to do these things. But you should try yourself. You should try to do it yourself. And if you can't, then you can spend a lot of time plug through. This is 3.14. By the way, see, it's easy to look right up here, see where you are, in case you got to do all these, in case you got to plug through and find a particular one. It always says right up here, what's going on? Why am I talking so much? Okay, here we're doing 3.1.5. How far do I get here? 3.1.5. Look at the syllabus. Oh, okay, good. 3.1.5. It looks like I go all the way. All right, so that should cover chapter 3. I'll upload this video and we'll put it down right here. And I'll see how you guys do. I'm going to put up another forum question pretty soon. And then next week, I guess we'll get into chapter 4. I'll take a peek at these because these are some pretty long chapters. My goodness, chapter 5 is pretty long. It's pretty important stuff in there. Actually, chapter 4 is pretty important stuff too. And so I might use a couple class periods for that. So make sure you go in and you mark off. I hate it when it does that. Click on. Please keep up to date when you can sit in a class. Click on here, and it's I changed the domain name to cansit.in. And this was my schedule for this week. And I'm going to announce this probably in the email, is that when you see this, I'm going to show this to you every week. If you want to have an office hour with me during any of these times here that are not taken up by class, then just email me that day or text me or something. And on a pretty short notice, I can just meet with you during these times. Because what I've decided I'm going to do is I'm going to put my schedule. I'm going to build this first the week before. I'm going to put in like my schedule, and then I'm going to decide when I'm going to have these classes. But like for instance, it's Thursday, and I got to go leave to pick up my sister from work here. So that's why I don't have these free. But anyway, I generally have all these free. I don't always have these days free. But anyway, so keep that in mind if you ever have any problem. And sometimes you might get on and just talk for 5 minutes, and you go, okay, I got it. Thank you. And then that's it. And very easy to do. All right. Any questions? I will see you next week. Thanks for watching.
Thank you.